Okay, in this lesson, we're going to be dealing with rational expressions, and the word rational, I want you to think fraction when you see that word. In this lesson, we're really dealing with a bunch of fractions, and the fractions we deal with are going to have x's, they're going to be factored sometimes, and they're going to look kind of complicated and messy, but we are going to simplify them. We're going to add, subtract, multiply, and divide these fraction expressions. So let's go ahead and write down what rational expressions are. Make a little note. Think fraction expressions. Basically, it's a polynomial over a polynomial. For example, a polynomial is just like a normal problem you might see involving x's. So a polynomial on top could look like x plus 2. X plus 2 is a polynomial. On bottom, it could be x squared plus 4x plus 4. Basically, any of the things you see in algebra, those are polynomials for the most part. So we put a polynomial over a polynomial, and that is a rational expression. There's an example. We're going to be dealing with stuff that looks like that. We're going to be factoring the top and bottom in some problems, and we're going to be simplifying these so that we can add, subtract, and multiply and divide. And when we simplify, we'll have to be canceling on top and bottom of our fractions. So it's really important that we understand what you can cancel and what you can't cancel. So when you have a fraction and you want to simplify it, you can cancel factors, you can't cancel terms. So let's write that down. You can cancel factors on top and bottom, but you cannot cancel terms, and I will show you what I mean when I say that. First of all, factors usually look like this, and terms usually have pluses and minuses in between them. So factors are all multiplied together, whereas terms are separated with pluses and minuses. So let's look at an example using just some basic numbers. In example number 1, this is 6 times 4 on top and 6 on bottom. And in the non-example number 1, I'm using the same numbers, but I'm changing from a multiplication sign to a plus sign. So these would be factors, and these would be terms. 6 and 4 are terms. Factors can cancel on top and bottom. Terms cannot cancel on top and bottom. So when I head to example 1, I see that I have a matching set of factors that can cancel on top and bottom. And I'm left with the answer 4 over 1, or just 4 after canceling. Think about it. 6 times 4 over 6 is 24 over 6, which does equal 4, so this does work. And the reason is, when you take 6 times 4 and you get 24 on top, but then you reduce it by a factor of 6, so you're dividing out a 6, really what you're doing is you're reducing the 6's that are already inside the 24. It gets a little trickier though when you think about x's. It's easy with numbers, but tricky when we can't tell what things equal. But in example 2, we see factored form on top. And so because we have factors, we can cancel them with matching factors on bottom. On the bottom, I don't have factored form because there's only one set of parentheses here, but I can take this entire thing and I can cancel it with the factor on top, just like that. X plus 3 is a matching factor on top and bottom. And I know that nothing is being multiplied to the x plus 3 on bottom, so you could think of it as like a 1 is out there being multiplied to it. Either way, you're allowed to cancel the entire x plus 3 with any factor that matches up top. Heading to my non-examples, if I were to have 6 plus 4, which are two separate terms separated by a plus or a minus sign, if I tried to cancel my 6's, I would get 4 over 1, which is 4. Is that correct? Well, let's try and see what happens if we were to actually add 6 plus 4. 6 plus 4 on top would be 10. 10 over 6 is not the same as 4. Therefore, this is wrong. And we cannot cancel terms. So if you take a look at number 2, a common mistake would be to cancel out the x's on top and bottom and say the answer is 3, but that is incorrect. The reason it's incorrect is x and 3 are terms on top. So we can't cancel them individually. Okay, the last thing I want to mention before we get going is key ideas for canceling factors are going to be factor on top and bottom if possible, then cancel matching factors. Example 1 is all about deciding whether we can or cannot simplify something. And what we're looking for to simplify would be matching factors on top and bottom, which means we would need factored form, or we would need the entire top to be able to be canceled with an entire factor on the bottom, or vice versa. So let's go straight into it in example 1. It says simplify if possible. And what I notice here is that x squared has a plus sign in between the 3 and the x squared. So they cannot be individually canceled with anything. They can be grouped together and canceled with a matching group on the bottom, but I don't see an x squared plus 3 on the bottom, and I don't see a 2x on top, so this can't be simplified. Heading to B, on top, I've got terms x and 2 separated by a minus sign, so they cannot be individually canceled, but you can group them together, and if you can find a matching group on the bottom that is a factor, then you can cancel those things. So I can cancel x minus 2 on top and bottom, and I'm left with a 1 on top and an x plus 4 on bottom. You don't need the parentheses. There is nothing else you can do, so that is as simple as it gets. Heading to C, it looks very similar. On top, you have x minus 5, which is separated with a minus sign, so they can't individually get canceled, but the entire x minus 5 could get canceled with an x minus 5 on the bottom as long as it's a factor. Well, looking at the bottom, I do see an x minus 5, but you have to ask yourself, is it a factor? I can only cancel matching factors. There's a plus sign separating it from the other set of parentheses. So x minus 5 and x minus 2 are not in factored form because they are not being multiplied. How do I know they're not being multiplied? There's a plus sign in between. Okay, so if we were multiplying them, there would be nothing in between. They would be right next to each other, but these are not in factored form. So x minus 5 cannot be canceled. And if you think about it, on top, x minus 5 is still there. On bottom, x minus 5 plus x minus 2, and we don't really need the parentheses when we have a plus sign in between. We're not multiplying anyway. There's nothing to distribute. There's no reason to even have parentheses there. I've got x minus 5 on top, 2x minus 7 on bottom, and really there's nothing I could do other than that. This is as much as I could simplify, and it did not involve canceling. So this is what this equals. Okay, the last problem I'm going to do from here is going to be D. And I notice the top is in factored form. I'm going to color code each factor individually. It's 2 being multiplied, x being multiplied, and x minus 5 as a group being multiplied. So the reason I color coded 2 and x separately is because even though, yeah, you see 2x together sometimes, they're being multiplied. So technically, they are their own factors each. X minus 5, though, has to stay together because it's got that minus sign in there. On the bottom, I'm going to color code any factor that is the exact same thing. So I see x minus 5. I'm going to color it the same color. I see a 2. I don't see an x individually. And then I would say x minus 2 is another factor, but I don't see it anywhere else in this problem. I can only cancel matching factors. By the way, this would be factored form on top and bottom. And I can cancel the ones that match. So my 2's match, my x minus 5 matches, and what I'm left with is x over x minus 2. This would be as simplified as it gets. The last 4 would be for you to try and check your answers with me. Heading to example 2, this is extremely important. Before we can add, subtract, multiply, or divide fractions together, we have to be really careful with what x is allowed to be. So in the past, you have dealt with fractions before, but most likely you have not dealt with x inside of a fraction. And there are restrictions that are extremely important that you have to be aware of for every single problem in these notes. So in the box where it says domain of a rational expression, domain means what x is allowed to be. What are you allowed to plug in for x? And usually you can plug in anything you want for x, but when you have fractions, you have to be extra careful. So because fractions have a special rule where the denominator cannot equal 0, you will have to be careful with what x is allowed to be. So it's typed right here, because rational expressions indicate division and division by 0 is undefined, we must exclude all values of x that make the denominator equal 0 from the domain. Basically, the domain means what can you plug in. And normally, you're allowed to plug in anything you want. But with fractions, you can't plug in anything you want because you can't let your denominator equal 0. So for example, if I had 5 over x, well, then the domain is x can be anything other than 0. And that's a nice simple example because you can see, okay, the domain is allowed, I can plug in anything I want for x, anything. But if I plug in a 0, this is a problem because division by 0 is not allowed in math, and that is extremely important. Division by 0 is not okay. If you have 5 divided by 0 or 5 over 0, this would be undefined. It is not allowed. You cannot divide by 0. Problem. I'm going to do one more quick example to show you what happens if I change my denominator just a little bit. Let's go ahead and make, instead of 5 over x, 5 over x minus 1. In this example, if I plug in a 0 for x, it's actually not a problem, which I'll do off to the side. If you plug in a 0 for x, you end up with a fraction that doesn't have a zero denominator, which is totally fine. So it's not that you're not allowed to plug in a zero for x. You're just not allowed to have the denominator equal zero. So basically, we do not want x minus 1 to equal 0. So when we add 1 to both sides, we find that x cannot equal positive 1. And that is what we're going to exclude from the domain. So the domain is that x can be anything except for 1. And before we move on, you can put your pencils down, don't write anything. I just want to remind you guys that 0 on top of a fraction is perfectly fine. Like 0 over 2, for example, equals 0, and that's okay. That's not a problem. But anything divided by 0 is a problem because it's undefined. Your denominator cannot equal 0 for the final answer in the denominator. That's a no-no. But the numerator, it's okay. So when we figure out what x is not allowed to equal, we focus on the denominator only, because the denominator is the only part where we have to restrict what x is allowed to be. And so this is very important to get into before we go into examples where we multiply, divide, add, or subtract. In example 2, we are just excluding numbers from the domain, which means we are deciding what x can't equal. So x cannot equal anything that makes the denominator 0. Since the denominator can't equal 0, then x minus 2, which is what we have in our denominator right here, cannot equal 0. Therefore, the way you would write that in an equation is x minus 2 cannot equal, which is an equal sign with a slash through it, 0. You can still solve it the normal way, but that means adding 2 to both sides, and you're going to find that x cannot equal 2. Remember, the slash right here in the equal sign right here tells me that it's not allowed to equal that. So x can be anything other than 2. So in each problem, you have to specify what x can or cannot equal. And sometimes that's going to be really easy and quick, like in part A. And in other problems, it's going to take a little bit more work. So I'm going to do a few problems. In part B, what we want to make sure is that this does not equal 0. So how do we figure out what x is allowed to be and what x is not allowed to be? Factor. Factor x squared plus 5x. So I'm going to take x squared plus 5x and factor it by factoring out the GCF, which is x. Rewriting this in factored form would look like x goes out front and x plus 5 is what's left inside my factors. So now I can say that my fraction equals 7 over x times x plus 5. Now that I've rewritten my entire fraction in factored form in the denominator, I can tell what I'm not allowed to plug in for x. Anything that's going to make the denominator equal to 0 is what I have to exclude from my domain. So looking at my denominator only, which I do not want to equal 0, and I'll rewrite this off to the side, I can set each factor not equal to 0 and solve. X can't equal 0 because that's what my GCF is an x. So that's going to be excluded from my domain. And if I subtract 5, x also cannot equal negative 5. Those are the two values I have to exclude from my domain because if you plug them back in, they're going to make your denominator equal to 0. Head to C, and I'm going to write the steps out this time. Factor on top and bottom. But mostly on bottom because on bottom we can't equal 0. Top, it's okay to equal 0. Bottom, not okay. So we have to factor wherever we can. 9x can't be factored, but x squared plus 3x minus 18 can definitely be factored using our product sum. What multiplies to negative 18 and adds to positive 3? Well, this is part of the homework assignment you did for Intro to P6. You've already done the work and you know the answer is 6 and negative 3. Factored form here is going to be 9x on top, but on bottom, I'm going to rewrite x squared plus 3x minus 18 in factored form. X plus 6, x minus 3. Remember, when you have no number in front of x squared, you get to just use the shortcut, and this would be factored form. Now that the denominator is in factored form, I can check each factor to see what x is not allowed to equal by setting each factor equal to 0. X plus 6 cannot equal 0, and x minus 3 cannot equal 0. By subtracting 6 from both sides, I find that x can't be negative 6, and adding 3 to both sides of the other factor, x cannot be positive 3. So those are the two values I would exclude from the domain, because if I were to plug them back in, they would make my denominator 0. The rest of the problems are for you to do. In part D, you'll factor it the same way that I just did using the product sum. In part E and F, you're going to have a difference of squares for both of them. So just keep in mind you need your difference of squares for E and F is extra tricky because it also has a GCF. There are going to be 3 values in part F that you will have to exclude from your domain. So try these on your own, check your answers with me at some point, or they may be on OneNote. On example 3, I'm going to just do one problem following these 3 steps that you have on your own notes. So you can see these 3 steps from the video and from your own notes. I'm going to pick a trickier problem. I'm heading to C. The steps say that we want to simplify this, and really what we want to do is try to cancel stuff on top and bottom. So the goal is to cancel. But you can't cancel whatever you want. You have to only cancel factors, which means you're going to need to get things in factored form. And that means I have to take a look at the top and the bottom and ask myself, can I factor these? I'm going to give myself a little bit of space to try factoring them. So I'm going to try to factor the top and bottom separately, one at a time. And the top can be factored using our product sum shortcut, where we want to multiply to 5, add to 6. The numbers for that are going to be 5 and 1. This ends up being x plus 5, x plus 1. X squared minus 25 can also be factored using a difference of squares. One gets a plus, one gets a minus, and x and 5 go in both. I'm going to quickly color code to show you. I'm going to rewrite it off to the side. I've got x plus 5 on top with another factor x plus 1 right next to it, all over x plus 5, x minus 5. So my goal is to cancel factors, but I have to mention what x is not allowed to be. I can't cancel anything until I mention that x cannot be negative 5 and x cannot be positive 5. This is very important to say x cannot be negative 5 or positive 5. You can also say x cannot be plus or minus 5. These mean the same thing because they both mean that x can't be positive 5 or negative 5. Doesn't matter which way you write it at all, but I'll leave it like this. X cannot be negative 5 or 5. I'm going to rewrite one more time my factored form and show my work for canceling. And I can only cancel matching factors, which in this case would be x plus 5 on top, x plus 5 on bottom. Nothing else can be factored or canceled, no matter how much you want to cancel things. All you have left is x plus 1 on top, x minus 5 on bottom. And as tempted as you are to cancel x's, you just cannot. They're not in factored form. They're not factors. You can't cancel. In your final answer, make sure you include that x cannot be -5 and x cannot be +5. So the rest of that example is for you. You can factor, cancel, make sure you exclude from the domain, and follow those instructions. Everything that we've done so far is leading to be able to multiply and divide, add and subtract fractions where we can factor, simplify, and exclude from the denominator. But it's really important to remember what the rules are for multiplying fractions and dividing fractions. And in order to do that, I'm going to use basic examples. But first, I'll write the rules. When you multiply fractions, you multiply across the top and you multiply across the bottom. And a basic example of this would be 1/2 times 3/4. Notice I have two different denominators, but it doesn't matter. I don't need a common denominator when I multiply. I multiply across the top and I get 1 times 3, which is 3. I multiply across the bottom, I get 2 times 4, which is 8, and that would be my final answer. So multiplying just involves straight multiplying across the top and bottom. Dividing is very similar with one extra step. It's the top times flipped bottom, or first times flip next. I'm going to do an example using just basic numbers, using the same numbers as before. Top times flipped bottom would look like this. Top over bottom would mean take the top and multiply it by the flipped bottom. Okay, so when you're dividing, because dividing can mean fraction, you take the top times the flipped bottom and you multiply. So I change this to a 4/3. That's one way to do it, and in this case you get 4 over 2 times 3 is 6, and I could reduce it, but I'm not going to worry about it. Another way to deal with division, sometimes you don't have a top and a bottom like this. Sometimes you have a symbol for division. 1/2 divided by 3/4. In this case, what you would do is the same type of thing. First times flipped next. First times, you can put a time symbol, dot, it doesn't matter. Flipped next. So we flip this when we multiply. Then we get the same answer. Across the top is 4, across the bottom is 6. Point is, division can be a fraction or a division symbol. They both mean the same thing. Either way, it's top times flipped bottom or first times flipped next, where you multiply across the top and you multiply across the bottom. In example 4, you are going to multiply and divide these fraction expressions, and you're going to simplify if you can. You're going to exclude from the domain if possible, and it's going to be quite a few steps. I'm going to do one division problem and one multiplication problem. The first problem I do is going to be a multiplication problem. I'm going to do B because there is quite a bit of factoring involved in B. I'm not going to go through every single step of factoring. because you've already done this in your Intro to P6 homework. But I will write it out in factored form and show you all the steps for multiplication and simplification where we exclude the domain. I'm going to highlight the areas that I think could be factored. I think this can be factored, which I will try. I think this is a difference of squares, and I think this can also be factored. It's important to make a note anytime you see a difference of squares, just so you start to remember the pattern. I'm going to go ahead and give you factored form of all three of those pieces, and I'm going to leave x plus 3 alone because it can't be factored. X squared minus 4 is a difference of squares, so I could put x plus 2, x minus 2. So there is my first fraction. My second fraction can be factored as well on top and on bottom. And if you were to do the product sum, where you need a product of -6 and a sum of -1, that's going to be -3, +2. Shortcut x minus 3 and x plus 2 are your factors. On the bottom, I can also factor using product sum. Or you can also use the perfect square shortcut, but I'll just go with product sum. Has to multiply to 9, add to 6, and my two numbers that multiply to 9 are 3 and 3, which also add to 6. So my factors are going to be x plus 3 and x plus 3. Now the top is factored, the bottom is factored, and I've color-coded everything that I've changed into factored form. Before I move on to trying to cancel anything, to trying to multiply anything, I want to look at my steps. So far I've factored numerator and denominator completely. Next, I need to exclude from the domain, so that's what my next step will be. I know that anywhere in my denominator, I don't want x to be a number that will make it equal to 0. And that means that I'm going to set each factor not equal to 0. I took each factor individually in the denominator now that it's in factored form, and I set it not equal to 0. If I subtract 2 from both sides of this first one, I find that x cannot equal -2. If I add 2 to both sides of the next one, x cannot equal +2. Taking a look at x plus 3 does not equal 0. Subtracting 3 from both sides, x cannot equal -3. And then finally, I see the same factor repeated, which means I'm going to get the same answer, x can't equal -3 again. So I have now excluded from my domain, which I will include in my final answer. But I'm going to rewrite this. I'm going to rewrite x plus 3 over x plus 2, parentheses, x minus 2, times x minus 3, parentheses, x plus 2, all over x plus 3 times x plus 3. I know that when I multiply across the top, across the bottom, and there's no reason anymore to have separate fractions because they're all going to be listed next to each other in factored form. So what it really looks like is x plus 3, parentheses, x minus 3, parentheses, x plus 2, parentheses. On bottom, x plus 2, parentheses, x minus 2, parentheses, x plus 3, parentheses, x plus 3 again. I'm going to go ahead and cancel anywhere that I can. I see an x plus 3 repeated on top and bottom right there. I see an x plus 2 repeated on top and bottom. And I don't see anything else repeated on top and bottom. So on top, I have x minus 3. No parentheses needed because it's not being multiplied to anything. On bottom, I have x minus 2 and x plus 3. And I'm going to keep the parentheses on each of those because they are going to get multiplied together. I cannot do any more simplification at all. So my final answer will be this. However, it does need to include the fact that x cannot equal negative 2, positive 2, or negative 3. And that was a very important step in this problem. I'm going to do example C, but I'm going to do it a little bit quicker. And the difference here is we are now using a division symbol in between. I want to start off by factoring the top and bottom of each fraction individually, but I'll color code the ones that I think can be factored. This can be factored up top in the first fraction, and this could be factored down below in the second one, or in the first fraction as well. But in the second fraction, I can't see any factoring that needs to happen. So I'll go ahead and factor off to the side, x squared minus 2x minus 8. I'll do the work for you. That's going to be x minus 4 and x plus 2. That's what I get on top when I factor. On bottom, x squared minus 9 is a difference of squares. And when you have a difference of squares, one gets a plus, one gets a minus, x and 3 go in both form. Now I'm going to rewrite my fraction, but it's going to be in factored form for my first fraction. X minus 4 times x plus 2 all over x plus 3 times x minus 3. Division symbol, x minus 4 over x plus 3. All I have done so far is turn the top into factored form and turn the bottom into factored form. That is the only thing I've done. Don't do anything else until you exclude from the domain. Before you try to flip anything, before you try to take first fraction times flipped second fraction, you need to tell me what x cannot equal. And looking at the bottom, x cannot equal anything that's going to make the bottom equal to 0. I've got some factors here that I can set equal to 0. X cannot equal negative 3. X cannot equal positive 3 because of these first two factors. And then x can't equal negative 3 again, which I have already put in my restriction, so I don't need to write that twice. So now that I know what x is not allowed to equal, I'm ready to divide. When you divide, you take your first fraction and you switch to a multiplication symbol. So no more division, we're switching to multiplication, and you times it by your flipped second fraction. So on top, we're going to put x plus 3. On bottom, we put x minus 4. Now we're ready to multiply. It is first times flipped second. And this is what I do anytime I'm dividing. All right, when you multiply across the top and across the bottom. So I'm going to go ahead and put some parentheses around my second fraction, and I have across the top x minus 4, x plus 2, x plus 3. On bottom, x plus 3, x minus 3, and x plus 4. Or I'm sorry, x minus 4. I've already excluded from the domain. Remember, we did this earlier. You have to do this before you divide. But now I have a new part of my denominator. Now there's something new that x is not allowed to equal. Well, I already know that x cannot equal -3 or +3. That's very important. And I already know that, so I don't have to worry about that because I've listed that. But there's another new number now that I've flipped things that x cannot equal. X cannot equal +4. And this is new. So my final exclusion is that x is not going to be -3, +3, or +4. So I need to know that. The next thing I need to keep in mind is that I can cancel stuff. I can cancel matching factors on top and bottom now that it's in factored form. So this is x plus 2 on top, x minus 3 on bottom. And don't forget that x is not allowed to be -3, +3, or positive. So the tricky part about division, you have to exclude before flipping and after. You guys have a couple to do. You're going to do a multiplication in part A, you're going to do a division in part D, and that's it for multiplication and division. Okay, we've multiplied fractions, we've divided fractions, and now we're going to add and subtract fractions, and that is everything we're going to do with fractions. The part that is tricky when you add or subtract is having a common denominator. Sometimes you're given a common denominator, which means you have the same denominator. Common denominator means same denominator. And an example of that is going to be just using basic numbers. Let's say 5 out of 13 plus 4 out of 13. Well, we have the same denominator, 13 in both. So our final answer is going to have a 13 for the denominator because you have to keep the same denominator when you add or subtract. You keep your same denominator, you add or subtract across the top, and final answer here would be 9/13. So when you have the same denominator, it's nice and easy because you just keep the denominator the same, but you add or subtract the numerators. Same denominator is simple compared to different denominator. Different denominator would be, for example, if I had 2/7 minus 5/3. What I notice immediately is the denominators are not the same, so I can't put a 7, I can't put a 3, I cannot add those together, I can't subtract them. There's nothing you can do to get a denominator for your final answer other than the work that it takes for getting a common denominator. To get a common denominator, you are going to have to multiply each fraction by a factor that can produce something in common. So I want to look at my fractions. I want to ask myself, is there something I can multiply 7 that's going to give me a 3? No. Is there something I can multiply 3 by that's going to give me a 7? No. Is there something I can multiply each of them separately by that will make them equal to each other? Yes. And think about what number is it that you can multiply each of these 7 and 3 by that will make them equal each other. Sometimes it's going to be a nice low number. Sometimes you have to multiply 7 and 3 together to figure it out. In this case, the lowest number that they both could go into would be 21. And I know that because 7 times 3 is 21. So you will have to get a common denominator by multiplying the top and bottom by whatever it is that's going to give you the same denominator. In my first fraction, that happens to be 3 on top and bottom. But in my second fraction, that actually is 7 on top and bottom. So when I rewrite these fractions, I've got 3 times 2 is 6 over 21 minus 5 times 7 is 35 over 21. And now I have a common denominator of 21. And our common denominator is what's going to be part of our answer. On top, 6 minus 35, which equals negative 29, which is allowed. You're allowed to have a negative number. So just to recap, we got a common denominator of 21 by multiplying 7 and 3 by each other, actually. That stays our denominator, and then we take our numerators and we add them or subtract them to get our final answer. But your common denominator needs to stay your final denominator. Common denominators do not get added or subtracted. They stay the same whenever you add or subtract. So let's do some problems. And I put the steps up in the notes, but basically in this example, you're going to have a common denominator. So we're not going to get to the tricky stuff yet till the next example. But in this example, you're going to have a common denominator. All you have to do is add or subtract across the top only, which means keep your denominator as is. Add or subtract across the top. In this case, we're subtracting for part A, and you have to subtract every part of the next fraction. You have to subtract 4x. You have to also subtract negative 2. And this is going to change the sign for both pieces. So this minus sign here affects both of those pieces. Be very, very, very careful with that. That is one of the most common mistakes, is when you are subtracting, you have to send that subtraction sign to both terms. And both sides change. So my common denominator stayed the same. It's x squared minus 9. And my numerator I've now subtracted across the top, which means I distributed my minus sign, and I will now combine like terms. 5x and negative 4x make 1x. Then the 1 and the 2 make 3. I'm dealing with x plus 3 over x squared minus 9. So we did all the hard parts of adding or subtracting. Now it's a problem just like the previous problem. What you want to do is simplify if you can, exclude from the denominator. Can we simplify this? And what needs to be excluded from the denominator? Well, the best way to tell and the best way to simplify is to factor. You have to factor anywhere you can. And what I notice is I can factor x squared minus 9, which equals x plus 3 and x minus 3, because it is a difference of squares. So let's rewrite this one more time. I have x plus 3 on top, x plus 3, parentheses x minus 3 on bottom, and I can see some things that I could cancel. This would be what I get after I subtract my original problem together and factor everything that I can. So I've done all the work, and I want to cancel stuff, but you have to be very careful. Before you cancel anything, you need to tell me what x is not allowed to equal. X is not allowed to equal -3, and x is not allowed to equal +3. And only after telling me what you're allowed to cancel, or what you're excluding from the domain, then you're allowed to cancel. Now that I know that I'm excluding -3 and +3, now I can cancel these guys. And I'm left with on top just a 1, on bottom x minus 3, and I'm going to put a comma next to this for my final answer to say that x is not allowed to equal -3 or +3, because that has to be included in my answer. I'm not going to do any more from example 4. You can rewind if you need to. Follow the steps that I gave you because they're listed at the beginning of example 4. For every problem though, you'll see that you have a common denominator already. So all you need to do is add or subtract across the top, keep the common denominator, and then you want to factor if you can, exclude what can't be in the denominator, and cancel to simplify. Like I said though, go back to the previous example that I did if you need to rewatch it, or look at the steps that I gave you, 1 through 3. I'm heading to example 5. In example 5, we're getting ready to add or subtract fractions that don't have the same denominator. Because in example 6, if I keep scrolling, you're going to notice our denominators are different, and we have to add and subtract when our denominators are different. So we're going to practice that in example 5, just making sure we know how to find a common denominator. I'm going to do 2 problems from here, and I want you to notice that my denominators are not the same. So the way to make our denominators the same is to multiply each fraction on top and bottom by the factor it's missing. Don't write what I'm about to write. You can put your pencils down. Off to the side, a basic example of this would be if you had the fraction 2/3 plus 5/7. If I had this fraction with different denominators, I could not possibly combine it into a common denominator just by adding them together. You have to multiply each fraction by the factor that it is missing to get a least common denominator. You have to ask yourself, what is the lowest number that 3 and 7 both go into? Well, usually that would be just found by multiplying them together, and it's 21 in this case. How can I get a 21 in each fraction? Well, I'd have to multiply the first fraction by 7 on the bottom. If you do it to the bottom, you have to do it to the top. And in the second fraction, I'm going to have to multiply it by 3 on top and bottom. And a lot of times you're going to find that you can actually just take the other factor that it's missing and multiply it on top and bottom. That's what's going to happen in this problem and in most of these examples. So I've got on top of my first fraction, 7 times 2 is 14 over 21 plus 5 times 3 is 15 over 7 times 3 is 21 again. But I have a common denominator, which was my goal. Across the top, 14 plus 15 is 29, and this would be my final answer. I'm showing you this example because what I did here was I took the denominator that I had in my other fraction and multiplied it on top and bottom to my other fraction that was missing it. In the fraction 5/7, I saw that I had a denominator of 7, so I multiplied the 7 on top and bottom to my first fraction. And that's pretty much what you have to do in all of these problems. You're gonna get a common denominator by taking each fraction and multiplying by the factor it's missing. I'll show you. X plus 2 over 2x minus 3, 4 over x plus 3. Well, I can see that this denominator is not the same as this denominator over here, so I need it on top and bottom. I can see that this denominator is missing from this first denominator over here, so I need it on top and bottom. And the way that it works to get your common denominator is to multiply the top and bottom by the factor that you're missing. Now that I've multiplied each fraction by the factor that's missing from the other one, I can rewrite this as x plus 3 times x plus 2 all over x plus 3 times 2x minus 3 and 4 times 2x minus 3 all over x plus 3 and 2x minus 3. I say this just to show you that now I magically have common denominators, so these fractions are now allowed to be added or subtracted because they have common denominators. Originally, we could not add or subtract them together. Now we can. In this very last example, which I'm so excited to be finally at the last example because this is the longest set of notes of my whole life, I'm going to skip to the most difficult problem of all of them, and you guys will do the rest. I'm going to skip to C. It is most difficult because there's factoring involved, because it's messy, because your denominators do not match. And so when I look at my two denominators that I want to combine together, but I can't because they don't match, I think, what the heck am I supposed to do? I have no idea. So when in doubt, factor. Let's see what happens if I put the denominators in factored form, which I will do very quickly because not only do I want this video to be done and you want this video to be done, but believe it or not, you've done these problems already on your Intro to P6 homework if you actually did the homework I assigned to you. And I hope you know that homework is assigned for a purpose because this would be the purpose for assigning that homework. All right, I'm going to go ahead and factor everything for you because I'm a nice person and because I'm getting tired of this. In the first set of factors, in x squared plus x minus 2, I can factor that into x plus 2, x minus 1. In the next set of factors, which is a difference of squares, I can factor that into x plus 1, x minus 1. And these are not common denominators. Unfortunately, we have to do a little bit of work if we want to combine them together. And we do want to combine them together because I said so. We have to combine them together because that's the whole point of this problem. So in order to combine them, we need the denominators to match. And what you want to do is see, well, what should I put on each fraction, top and bottom, that's going to make a match? What do I already have that does make them match? So far, my matching things are x minus 1. And my missing things are x plus 2 and x plus 1. All right, x minus 1 is good. We already have that. But what am I missing from my yellow factor? I'm missing an x plus 1. And what am I missing on my blue factor to make this match? I'm missing an x plus 2. Take a minute and make sure you're understanding that now that I've multiplied x plus 1 to the first fraction and x plus 2 to the second fraction, I would have a common denominator in both. They have matching factors across the board. The only problem is you can only do it to the bottom if you also do it to the top, so I'm going to do it to the top on both. That's the rule. You just have to do it to top and bottom. Otherwise, you're changing things that you're not allowed to change. I'm going to rewrite this though. Now I've got x plus 1, parentheses x plus 3, on top of my first fraction. I have my common denominator, x plus 1, x plus 2, x minus 1, on the bottom of my second fraction. And then in my, bottom of my first fraction. In my second fraction, 2x plus 2 all over x plus 1, x minus 1, x plus 2. Be very proud of yourself because you just made common denominators happen, which is really hard work when it comes to these types of problems. Honestly, it is. So now that we have common denominators, we can add things together. Add the numerators together on the top, x plus 1, x plus 3, plus 2 times x plus 2. Common denominator goes on the bottom one time only. Don't write it twice. That's the whole point of a common denominator. It becomes your denominator when you add. And you think you're done, and you're almost done. You're kind of done. You're pretty much done. You added. You have a common denominator, and you are so special for doing that. And I'm proud of you. But you still have to, first of all, exclude. What do you need to exclude? You can't let x be negative 1. You can't let x be negative 2. And you can't let x be positive 1. Those are no-nos. That has to be part of your final answer. The other super annoying part of this is that now that we've added everything together on the top and bottom, we are going to simplify the numerator by foiling. Foil the numerator. Slash combine like terms. So I'm going to foil x squared plus 3x plus 1x plus 3 for this piece. I've got a plus sign in between, and then I have 2x plus 4 for my second fraction right here. Common denominator hasn't changed, and actually don't even mess with it. Leave it in factored form. I want to point out that you should always leave things in factored form when they're in factored form. Don't change it to be not in factored form anymore. But the top of this was not in factored form. The yellow and the blue had a plus sign in between, so we never had factored form up top. That's why I distributed and foiled. But on bottom, we had factored form, and we want to keep it that way. So let's combine our like terms so we can be done with this problem. X squared is the only x squared I see. My like terms for x to the first power, which would be 3x, 1x, and 2x. 3 plus 1 plus 2 is 6x. Lastly, my numbers that have no x's at all, 3 and 4. Positive 3, positive 4 makes positive 7. And on bottom, x plus 1, x plus 2, and x minus 1. Final answer? Well, that's it. Actually, that's almost it. You have to remember that x is not allowed to be negative 1, negative 2, or positive 1. It's annoying, but you have to put that in your final answer. The box goes around this part too, super important. Don't forget to exclude from your domain. And yeah, that's the most annoying problem of all the problems that you're going to do in all the lessons that we ever do.